In this video, we're going to talk about one particular form for the equation of a line. Specifically, it's called the point-slope form. And it's called that because if you're given any point on the line and you're given the slope, it takes no time at all to write down the equation of that line. In fact, the formula looks like this. Let's see, x1, y1 is one point that's on the line and it has a slope m. So we do y minus y1 is equal to m, the slope, times x minus x1, and that's it. That is the equation of the line. If you're given the slope m and 1 point, x1 comma y1. Okay, so let's just do several examples. Given the following slopes and or points, find the equations of the following lines. Slope 6, and it passes through this point, or you can say this point, this ordered pair is on the graph of the line. So this is x1, y1, and that's m right there. That's all we need. Just plug y1 in there, x1 in over there, and m right there. So we'll get y minus y1, which is negative 5. Make sure you get the signs right. It's always y minus y1 equals m, which is a 6, times x minus 2. And that's it. I usually wouldn't leave it like this. I would simplify this to be y plus 5 equals 6 times x minus 2. And that's it. That's all there is to it. Let's do another. Slope of 0 passing through this point. So there we have x1, y1, and the slope m is 0. So we'll take y minus y1, which is negative 3, equals m, and I really don't need to do much more than that because m is 0, but I'll go ahead and write x minus negative 2, which is really x plus 2, and this is really y plus 3, but that's 0. So this really would simplify simply to y, that's plus 3, so I'm going to subtract 3 from both sides, equals negative 3. That would be the best way to write that, although it was fine to keep it up there with y plus 3 equals 0. If you're not instructed the form of the line to put your answer in, either one of those would be fine. Okay, the next one. And again, this one looks so simple simply because the slope was 0. Slope is negative 3, that's m, passing through negative 5, 11, that's x1, y1. So y minus y1 is y minus 11 equals m is negative 3, and then in parentheses we put x minus x1, but x1 is negative 5, so x minus negative 5. And again, a nicer way to write that would be y minus 11 equals negative 3 times x plus 5. So if you're given a point and the slope, it's very easy to plug in and get the equation of the line of the slope of the given slope that passes through that one point. Okay, so now we put our thinking caps on for this next one. What are we missing here? This is a point, and this is a second point. Well, you only need 2 points to define a line, but there isn't a formula called the point-point formula or the point-point form. So what we're going to do is use one of those points for this given point, but for the slope, we just use the slope formula using those 2 given points to compute the slope. That's the first thing we do. That's the only extra work we have to do in this case. So the first thing we do is m. Remember what it is. As a reminder, we'll put y1, I'll do y1 minus y2 over x1 minus x2. As long as you're consistent with those indexes, it's fine. You could also say y2 minus y1 over x2 minus x1. So I will do 1 minus 6, y minus y, and then do x minus x, negative 2 minus negative 1. So that gives us on top negative 5, and on the bottom negative 2 plus 1 is negative 1. Another time we get the slope of simply 5. So m equals 5. That's not our final answer, but now which of these points do we want to choose to plug in? It makes absolutely no difference. Just choose your favorite one. So I'm going to go with this one. Y minus y1, which is 1, equals 5 times x minus negative 2, which means x plus 2. This is one way to write the correct answer. We could have chosen the other point, and we would have got y minus 6 is equal to 5 times x minus negative 1. X minus negative 1 is x plus 1. You don't need to do this. You don't need to use both of them. And it doesn't look like they're the same line, but these two equations are absolutely equivalent. Let's see. We could verify that by choosing an ordered pair. Let's see. If x were a 0, what would y be? If x were a 0, we would have 5 times 2. We'd have 10 on the right-hand side if x were a 0. And we'd have y minus 1 equals 10, which means y would be 11. So all I'm doing here is doing a sanity check. 0, 11 is on this line, because if we replace x with 0, we get 10 on the right-hand side. And if we replace y with 11, we get 11 minus 1, we get 10 on the left-hand side. Let's make sure that this point also works on this one. So if x is a 0, we get 5 times 1. 5 times 1 is 5 on the right-hand side. Y is 11. 11 minus 6 is 5. We get 5 on the left, 5 on the right. So these two are equivalent, and either one of them would be absolutely acceptable for a final answer on an exam. You can choose either one of the points. All right, let's do the same kind of situation. We have two points given to us, so we have to compute first the slope m. So negative 9 minus negative 1, negative 9 minus negative 1, over 1 minus 2. And that's equal to negative 9 plus 1, negative 8 over 1 minus 2, negative 1. That's just 8. Oh, we're getting lucky. None of the slopes haven't been fractions too frequently in our examples. So this is m. The slope is 8. All right, so I'll use this one right here. And I'm going to do y minus y1, which really means y minus negative 1, or y plus 1, equals m, which is 8, times x minus x1, x minus 2. And that is the equation of the line that passes through both of these points. Okay, one last one, and this is a special case. Special case, I'm not giving you the value of the slope, and I'm not giving you the value of the point other than the fact that the point where I'm giving you is the y-intercept. So that means that the x value is 0. Now we're going to call b the y-intercept, 0 comma b. So this is going to be y minus y1, which is b, equals slope m times x minus x1, which is 0, x minus 0. Let's simplify this a little bit. Y minus b equals mx. All right, x minus 0 is just x. And now let's add b to both sides. Y equals mx plus b. This should be probably the equation you remember, the equation of a line that you remember most from your previous classes. This is one you probably remember for your entire life. When you are given the slope, and if you're lucky enough to be given the point that is the y-intercept, we don't even have to go back through all of this point-slope form. We can just immediately write it in this form, which I'm going to talk about in the next video.